The focus of today's lesson is finding the average value of a function. So typically in mathematics, when we're finding the average, we take a set of values, add them together, and divide by how many values we added together. What this function here does is it will find that average if we were to take all of the values of f of x. So f of x at each of these individual points, add them up and divide by the number of values we added together, we would get what's called f average. And the average value of the function on a closed interval a to b is defined as f average is equal to 1 over b minus a from, the integral of f of x dx from a to b. And so we're simply going to be using that formula in order to find the average value of the function. So let's take a look. So find the average value of the function f of x equals 1 plus x squared on the closed interval negative 1 to 2. So our function f average is equal to 1 over b minus a. This is our a, this is our b. So we have 2 minus a negative 1, the integral from negative 1 to 2, 1 plus x squared dx. Okay, which becomes 1/3 the integral from negative 1 to 2, 1 plus x squared dx. Now we want to integrate, so we will take our antiderivative, which will give us x plus 1/3 x cubed. And then we are from negative 1 to 2, which becomes 1/3 2 plus 1/3 times 2 cubed minus negative 1 plus 1/3 negative 1 cubed. And then we'll go ahead and simplify this expression to get our answer. So we get 2 plus 1/3 of 2 cubed, which is 8, so 8/3, minus negative 1. Negative 1 cubed is negative 1, so minus 1/3. And then this becomes 1/3 times, and then 2 is the same as 6/3, so 6/3 plus 8/3 is 14/3. And then negative 1 is negative 3/3. So negative 3/3 minus 1/3 is negative 4/3. So we have 1/3 times 14/3 minus a negative 4/3, which is 18/3. But 18/3 is the same as 6. So 1/3 is 6, which is 2. So what this says is that the average value of this function here is 2 in that closed interval negative 1 to 2. All right, let's take a look at another example. Find the average value of the function f of x equals sine of x on the interval pi over 6 to 5 pi over 6. So we're essentially going to do the same thing as we did previously. So our f average is going to be 1 over our b, which is 5 pi over 6, minus our a, which is pi over 6, our integral from pi over 6 to 5 pi over 6 of our sine of x dx. Now this becomes 1 over 4 pi over 6 from pi over 6 to 5 pi over 6 sine of x dx. But note that 4 pi over 6 reduces to 2 pi over 3. So this here is really 2 pi over 3. But 1 over 2 pi over 3 mathematically is the same as 3 over 2 pi. So we're going to just invert that. We're going to do the reciprocal. So we have 3 over 2 pi, the integral from pi over 6 to 5 pi over 6, sine of x dx. Now we'll take our antiderivative of sine, which is negative cosine of x. So we have 3 over 2 pi, negative cosine of x, from pi over 6 to 5 pi over 6. Now really at this point, evaluating this just requires use of the unit circle. And we are taking a look at pi over 6, which is here, and 5 pi over 6, which is over here. So here we have our root 3 over 2, comma 1/2. And then over here we have the negative root 3 over 2, comma 1/2. And so we have here 3 over 2 pi, negative cosine of 5 pi over 6, minus a negative cosine of pi over 6, which becomes 3 over 2 pi. And then negative cosine of 5 pi over 6. Cosine of 5 pi over 6 is here. It's our x value. But it's a negative cosine 5 pi over 6, so it's a negative rad 3 over 2, or just rad 3 over 2. And then here we have minus a negative, so this is going to become plus. And then cosine of pi over 6 is root 3 over 2, so we get that right here. But root 3 over 2 plus root 3 over 2 is going to become just root 3, because it's 2 root 3 over 2, which is just root 3. So this is 3 root 3 over 2 pi. And that's our average value. All right, so now we're going to introduce what is called the mean value theorem for integrals. And it says this: if f is a continuous function on the closed interval a to b, then there exists a number c in that closed interval such that f of c is equivalent to that f average. Now, when you think about it, it makes sense. So because this f average is made up of function values for f of x, and it's the average, it means it must be between some values. Some values must be above and some values must be below. In this case, we could see that f of whatever this is here and f of whatever value this is here are equivalent to that average, which goes straight across here. So example 3 would like us to find a value c for which f of x equals 1 plus x squared satisfies that mean value theorem for integrals. And we're going to be on that same interval as on example 1, that negative 1 to 2. So they want us to find a c such that f of c is equal to our f average. Now, if we look back to example 1, our f average for this specific function was equal to 2. So what we're trying to do, and this is from example 1. Now, if we want to find the f of c such that this is true, let's find what f of c is. So here's our function. We're going to replace x with c. So f of c is 1 plus c squared is equal to 2. And we want to solve this for c. So let's subtract 1, and we get c squared is equal to 1. We'll square root both sides, and we get that c is plus or minus 1. So what this says is then, at the values of 1 and negative 1, our function is equivalent to that average value of 2. And when you look at the function, you could see that it makes sense, right? If I plug in 1, I get 1 plus 1 squared, which is 2. If I plug in negative 1, I get 1 plus negative 1 squared, which is also 2, and that was our average value. And that's it. Today's assignment is in your textbook, page 494, 7 to 25 odd. Feel free to message me with any questions.